Yeah. Hello everyone. Can you hear me? Yeah.
Yeah, we can hear you.
So before starting the session, I think all of you should make a Tinkercad account. So I will show you how to make the account first. Yeah. Give me 2 minutes. Um, can you see my screen? Yeah. Okay. First, yeah, search on Google Tinkercad and then click on the website. And then on the top right corner, you can see the sign up option. Click on it. And then here, click on create a personal account. So you can sign in with Google or sign up with email. With Google, it will be quicker, but I will show you with the email. So yeah, now fill these details and click on next. Yeah, then put your email ID and then create a password. Yeah, then create account and then done. So now you have logged in to Tinkercad and now you can see the Tinkercad user interface. So yeah, we use Tinkercad mostly for creating circuits. So to create a circuit, click on create on the right side and then click on circuits. And you can start creating circuits here. We will show you how to make a circuit later. Yeah, now we'll start with our presentation. Yeah, I guess you can see the screen. So yeah, today is session 3 of summer school. I bought summer school, and today it is the first electronic session, and we'll be talking about Tinkercad and Arduino. Today's session is taken by me. I'm Anish and Anup. So yeah, we'll start. Yeah, also, before starting the session, do follow iBot on YouTube and Instagram. Scan the QR codes and follow iBot. Yeah, I guess you have scanned, followed iBot. Yeah, today we'll be talking about basic sensors and microcontrollers. Then we'll be talking about L293D motor driver, which will be used to control two motors. And then I'll show you how to make a circuit on Tinkercad, the circuit to run two motors at the same time, and Anup will tell you how to code the Arduino microprocessor. So today's session will cover all these things, and we'll start. Uh, yeah, these are the main objectives of the session. Yeah, we'll start with the sensors. Yes, a sensor is a device that detects an input from a physical environment. The input can be light or motion or pressure, temperature, etc., or any other environmental phenomena. And the output of the sensor is generally a signal which is sent to a microprocessor or any other device and converted to a human readable display location at that location. And some of the common types of sensors, temperature sensors, pressure sensors, gas sensors, proximity sensors, and they are very important in modern technology because they enhance safety and efficiency. They enable smart technology like Internet of Things, IoT, and they're also critical for automation and data collection. Uh, yeah, so basic classification of sensors is yeah, active. There are active sensors. These sensors require an external power source to operate and generate signals. Examples are ultrasonic sensors, LiDAR, and radar. And passive sensors do not require an external power source. They can use a natural energy sources. Example is a temperature sensor, uh, passive infrared PR sensors, and photodiodes. The next classification is analog and digital sensors. Analog sensors, these sensors output continuous analog signals. These signals are proportional to the quantity which is being measured. An example is thermistors, pressure sensors, or strain gauges. Digital sensors, these convert physical quantities into digital signals in binary form. Example is encoders, digital thermometers, and digital cameras. And then there is then next classification. Next classification is contact and non-contact sensors. Contact sensors require physical contact with the object, and examples are tactile sensors, resistive touch sensors, and some temperature sensors. And non-contact sensors do not require a physical contact and can measure parameters without the contact. An example are ultrasonic sensors, infrared sensors, and capacitive sensors. And yeah, these are some of the essential sensors for mobile robots. The first is ultrasonic sensor. Ultrasonic sensors emit high frequency sound waves, typically in the range of 20 kilohertz and to 40 kilohertz. These waves bounce back upon hitting an object, and sensor measures the time delay between emission and the
Anish,
echo return to calculate the distance. So these
so
ultrasonic sensors
hello,
are
hello,
reliable for
Anish.
obstacle detection and navigation in various lighting conditions. Here we have shown the HCSR0 for ultrasonic sensor. See, it has one transmitter and one receiver, and it has four pins: VCC, trig, echo, and ground. I will show you on Tinkercad also how they work. Yeah, hello.
Yeah, Anish. So your voice is breaking. Can you do something like people are just saying in the chat? Like maybe your mic is too close, or like just if you can make it better, it's fine. It will be better. Otherwise, yeah, can't.
Yeah, I'll try. Uh, is the voice clear? Can you hear me, guys?
We can hear you, but like it's little sometimes breaking
Hello.
in between. Hello.
Can you just put in the chat?
Can you hear me?
Uh, yeah. Okay. Then we'll continue with the next sensor, which is infrared sensor. Infrared sensors, uh, they work by emitting infrared light and measuring the reflected light from nearby objects. They detect the presence of objects and estimate their distance. IR sensors are commonly used in line following robots, in remote controls, and in basic obstacle detection. Uh, they are cost effective and they have a quick response time. And they also have a transmitter and a receiver. You can see. And the next is a passive infrared PIR sensor. These sensors detect motion by sensing changes in infrared radiation emitted by warm objects like humans or animals. They do not emit any signals, but instead measure infrared radiation levels, making them common in security systems and automated lighting. Yeah, they have low power consumption and they are also easy to use. I will show you these on Tinkercad as well. Yeah, so this is a ultrasonic sensor. I have started the simulation. Now just check. Object is kept here in front of the sensor and it is calculating the distance between the sensor and the object, which you can see on the screen here. As I move the object, the distance is also changing. This is how a ultrasonic sensor works, and now this is the PIR sensor. Uh, See, when I move the object, the bulb will glow. At that point, it is detecting a motion change. The sensor is detecting a motion change, and thus it is used for security systems and automated lighting. Yeah, we'll move on with the section now. The next sensors. Yeah, the next is a LiDAR, light detection and ranging sensor. These sensors emit rapid pulses of laser light and measure the time it takes for these pulses to reflect off objects and return to the sensor. This time of flight measurement allows for precise distance calculations, enabling LiDAR to generate detailed 3D maps of the environment. LiDAR is crucial for precise navigation and obstacle avoidance, and it is used in mostly in drones and autonomous vehicles. And yeah, the next are cameras. Cameras are play a vital role in mobile robotics by capturing visual data used for 3D mapping, object detection, and navigation. Different types of cameras are there. The first is DOF, depth of field cameras. These capture images with different focus levels for 3D mapping. And then there are 3D cameras. These measure distance to objects, capturing three-dimensional images. And then there are stereo cameras. These cameras use two lenses to provide depth perception by comparing images. All these cameras are essential for object recognition, environment mapping, also provide detailed visual information for various robotic applications. Yeah, the next is IMU, the inertial measurement unit. This is also very important. This is a combination of accelerometers and gyroscopes to provide comprehensive data on robots' movement and orientation. So accelerometers, these measure linear acceleration and thus they measure the change in velocity of the robot. And gyroscopes measure rotational movement of the robot, and thus by integrating data from both And IMU offers detailed information on how the robot is moving and turning. This is essential for maintaining balance and precise navigation. Yeah, it is also used in drones, autonomous vehicles, and mobile robots. And the next sensors are encoders. So encoders measure rotation of the wheels or motors, and these uh, convert the angular position of the of the motor into electrical signals, and thus we get feedback, precise feedback on the accurate feedback on the uh, position of the robot, like how is it moving, and also about its motion. So it is important for accurate navigation and movement control in robotics. There are different types of encoders. Yeah, the first is absolute rotary encoders. These provide a unique position value or code for each angle of rotation, meaning they know their exact position after each cycle. And the next is incremental rotary encoders. These generate a series of pulses as they rotate, which can be counted to determine the relative position or speed. The next are linear encoders. These measure position or movement along a straight path. These are commonly used as a measuring instrument in measuring instruments. The next is optical encoders. They use light, usually LED, and a photo detector to detect position or movement. They provide high accuracy and resolution. The next are magnetic encoders. They use magnetic fields to detect position or movement. And these can be used in harsh environments where optical encoders might fail. Yeah, and the last type is mechanical encoders. They use physical contacts to determine position. These are typically used in low cost, low precision applications. And the next is strain gauges. Yeah, strain gauge is used to measure the strain deformation of an object. When the object deforms, the strain gauge deforms as well, causing its electrical resistance to change. The change in resistance can be measured and used to determine the amount of strain. Uh, so yeah, there are different types of strain gauges. Metal foil strain. First is metal foil strain gauges, and then there are semiconductor strain gauges, and there are also optical strain gauges which use light signals to measure strain, and they are useful in, yeah, but they are little costly. Yeah. And the last type of sensor which we'll talk today are capacitive sensors. So these sensors detect change in capacitance to measure various physical quantities such as position, humidity, or material properties. They work on the principle that capacitance between two conductive plates changes when distance between them or the dielectric material between them changes. There are different types of capacitive sensors. First is proximity sensors. These detect the presence or absence of an object. Then there are touch sensors. These are used in touchscreens or touchpads to detect the touch of the finger. Uh, there are humidity sensors, and then there are level sensors which measure the level of liquids or solids in a container. Yeah, so when the distance between the two plates change or the material, if there is a material in between them, such as your finger, then capacitance changes and the sensor detects it. So yeah, this was about sensors, and then now we will move on to microcontrollers. Yeah, Anup, you can start.
Yeah. Hello, guys. Am I audible?
You are audible.
Yeah. Okay. So, all of you might know that all robots and everything, they work autonomously and everything. But how do they work? So, the basic thing is everything needs a brain, right? So, microcontrollers are the brain of robots. The basic purpose is to control the robot's motion and everything. Microcontrollers consists of three major parts. It has a processor, it has memory, and it has input-output peripherals. Processor is the thing in which you code, and that will process your code and everything and all. The memory is where the code will be stored and the data through the sensors and all will be stored. And the input-output peripherals are the pins or uh, slots in the microcontroller where you can attach your motors, encoders, sensors. Everything is attached to the input output peripherals. So all the communication happens through input output peripherals. Moving on, we'll talk about some commonly used microcontrollers. All of you might have heard about Arduino Uno. Like it is the Arduino is mostly is used a lot in robotics related
Yeah.
projects.
Anup, I'm not
Yeah.
able to hear you.
Hello.
Anup, you're clear and you can go on.
Yeah.
Yeah, you're clear. Maybe the person who said is having internet issues. Please check your connection, internet connection.
Yeah. So Arduino Uno is used widely for robotics and IT related projects. The reason for that is like it has an optimum size, compact, it is very compact, so it can be fitted anywhere. It has optimum number of pins, it is compatible with many sensors, and Arduino has many libraries that can be used by people. Also, there are many references on Google which you can use in order to code Arduino, and it is very easy to code. Moving on, there is the ESP32 series. So it is a series of 32-bit microcontrollers, and it is low power consumption. It also comes with integrated Wi-Fi or Bluetooth, so it can be controlled via your phone or some other device. And there is the STM32 series. It is also a family of 32-bit microcontrollers, and it is developed by a company called STM Microelectronics. So let's move on. Anish, hello.
Give me a second. There's a small issue with Anish connection.
Yeah. Yeah, so we'll start with H-bridge. So we'll be using motor drivers today. And in order to, like most of the motor drivers are based on the H-bridge topology. So what an H-bridge is, like if you want to rotate a motor in clockwise and anti-clockwise direction without changing the polarity of your battery, the only like this is the way which we do it. So like as you can see in the circuit diagram, the motor is in the center and there is an H-like figure. So the arms of the H have four keys, as you can see S1, S2, S3, and S4. So among these four keys, when S2 and S3 are closed, the motor will rotate in one particular direction. And when S2 and S3 are opened and S1 and S4 are closed, the motor will rotate in the reverse direction. So you can change the direction of the motor without changing the polarity of the battery. That is the main purpose of an H bridge. Motor drivers are something which are which act like an interface between the microcontroller and your motors. Motors usually consume more power, and microcontrollers don't usually work on that much voltage. So we give higher voltage to the motor drivers, and the motor drivers help in controlling the motors precisely and controlling their speed and stuff. So moving on. Yeah, we'll talk about L293D. It is a motor driver that is in Tinkercad and we'll be using it today. So in L293D, there are 16 pins. L293D has two H-bridge circuits inside, and we can control two DC motors parallelly using it. So each set of 8 pins controls one motor. As you can see in the left pin diagram, there is an enable pin. There are two input pins, two output pins, and two ground pins, and one power pin. VS stands for power. So what happens is the enable pin is connected to a PWM pin on the Arduino, and the input pins are connected to digital pins on the Arduino, whereas output pins will be connected to your motor. Ground is connected to the ground of the Arduino, and VS is for the power supply. So that will be 12 volts in case of motors. So talking about the circuit diagram, as you can see, instead of keys, transistors are being used in this edge bridge. So what happens is, when input 1 is closed, input 1 is to the left bottom, if you can see. So when input 1 is closed and input 2 is opened, the transistors Q2 and Q3 are activated, and the current flows and the motor rotates in one direction. And when reverse, that is input 1 is opened and input 2 is closed, transistors Q1 and Q4 are activated, and the motor rotates in an opposite direction. So how it helps in speed control is that enable is the main part in a motor driver. So if enable pin does not have a potential, then the motor driver will not work. Like the motors won't turn on even if you give power to the input pins. Enable is the one that controls the power. So we can adjust the potential of enable using the PWM pins on an Arduino. So with that, you can also control the speed of the motor. So moving on. Yeah, so this is a truth table for L293D. As I explained, if you keep input 1 open closed and input 2 open, it rotates in a particular direction. And if you reverse that, it will rotate in the opposite direction. And if both are open or both are closed, it will obviously not rotate. And if, as you can see, the last row, if enable 1 is closed, like if enable 1 does not have potential, the remaining inputs does not matter. It will always remain closed. So yeah, moving on to Arduino Uno. Yeah, this is a diagram of the components and cable pins in Arduino Uno. So the left top is your power input. The middle, that big gray thing, that is a USB port with which you code the Arduino using your laptop. So you will dump the code into the Arduino through that. And to the left bottom, there are the analog pins. These pins can transfer data from 0 to 255. 255 is because it is an 8-bit, like the lines are 8-bit, so 2 to the power 8 you can transfer up to 255. So these analog pins can transfer 0 to 255 as their data. And the above ones are the power input and output pins, and there are the ground pins. Moving to the right side, there are 13 digital pins. These pins can be used to transfer high, low, or 0, 1 data. So these can only be binary. And the bottommost two pins are for transmitter and receiver. Like we won't be using it today, so it's not much of much importance today. And there are three LEDs in the middle. They are for transmitting, receiving, and one is for for pin 13, which you can check if the board, like for a basic program. And it also has a ground pin on the right side. So out of the 13 digital pins, there are 6 PWM pins. These PWM pins, like PWM is a method that Anish will explain going forward. And PWM pins can be used to transfer analog data through digital pins. So we will be connecting enable pins of the L293D to these PWM pins. So yeah, I guess Anish will start about Tinkercad after this.
Guys, we'll stop the session for 5 minutes. Like you can ask your doubts, or you can just use the chat to ask your doubts. After like a certain couple of minutes, Anish will start continuing the session.
Yeah, so to the left side, there are 6 analog pins. And these analog pins can transfer a value between 0 to 255. That is because of it works on an 8-bit 8-bit pin bus. So like 8-bit means 2 raised to 8, that will be the value. So 0 to 255, these 256 values can be transferred. And the power pins are like, there is a 3.3 volt pin, which is the input pin. 5 volt is the output pin. Like you can get an output of 5 volts from your Arduino. And there are two ground pins, and there is a power input pin. Like if you are using a battery for the Arduino, you can get an input from there. Like you will connect it there. PWM pins Anish will be explaining later on. And so it also can. AREF pin we won't be using today, so like not to create more confusion and also, yeah.
We'll stop screen share for a minute, and then like there's a small internet issue. So just give us a couple of minutes and we'll solve it.
Yeah, so about the transistors, like what happens is when input 1 is closed and input 2 is opened, transistors Q2 and Q3 will will get activated and the current will flow. So in that way, the motor will rotate in one direction, let's say. And when input 2 is closed and input 1 is opened, it will get reversed. Like the transistors Q1 and Q4 will get activated, and it will rotate in the opposite direction. Every time one NPN and one PNP transistor will be activated. Yeah. So that's it. If you want more info, I have attached the reference link down here. Like you can view it later in order to get a more in-depth understanding of the transistors.
Sorry for the inconvenience. Anu, now Anish will start presenting the screen and will be explaining about PWM and further discussion about this session.
Oh, yeah. So yeah, Tinkercad is a free web-based application. It is developed by Autodesk and it is used mostly to design circuits. Yeah, and it's a very user friendly interface. And I will show you how to make the account again, and then we will go on with making the circuit for today. Yeah, before making the circuit, you should know about the breadboard, which is essential part of electric circuit of a circuit for prototyping. So yeah, breadboard is a rectangular board. It is used for constructing and prototyping and testing electronic circuits without the need for soldering the wires and the ICs. Seat, and it has a grid of interconnected holes into which electronic components and wires can be inserted. So yeah, then the holes are internally connected, and I will tell you how they are connected. So yeah, there are two two at the top and two at the bottom horizontal power rails. These are used for distributing power plus and minus to the components. And at the central area, there are terminal strips, and these are what and each strip is connected vertically. They are the same voltage. The vertical columns, they are at the same voltage, and yeah, they are connected internally. And the top and the bottom, they are horizontally connected. And yeah, now we'll move on with the technique uh, concept pulse width modulation, uh, which is used which is used for controlling the motors. So yeah, PWM is a technique which is used to control the amount of power delivered to an electrical device by switching the power on and off very rapidly. The switching happens at so high frequency that the device perceives it as a constant level of power, even though it's actually being pulsed on and off. Yeah, in PWM the signal is turned on and off at high frequency, and so another term is the duty cycle. Duty cycle is the percentage of time the signal is on or during one cycle. So, for example, 100% duty cycle is the signal is always on, and 50% duty cycle, the signal is on for half the time and off for half the time. And similarly, you can see the 75% and 25% duty cycle. Yeah, PWM is efficient way to control power. Uh, by adjusting the duty cycle, we can precisely control the amount of power delivered to a device. And so yeah, this is how PWM is used in L293D motor driver. So for direction control, uh, you for the motor to rotate forward, you have to keep the input one pin high and input two pin low, and vice versa for backward uh, backward motion, and same for motor B. And for speed control, you have to connect the PWM signal to enable pins of the motor driver, and then you can vary the duty cycle of the PWM signal to control the speed of the motors. Uh, yeah, this is about PWM. Now we'll start with circuit building. So search on Google Tinkercad. Yeah, directly. Now, yeah, click on sign up. Then create a personal account. You can sign up with email or sign in with Google. I'm signing in with Google only. Now, create an account. I hope you are following me.
And also make sure you use the same account which you have used for creating Fusion. So all these things are CAD software, so they belong to the same software.
Uh, Fill in the details and then create a password and login. And you can see the Tinkercad dashboard here. So click on create. I hope you have reached till here. And then create a circuit. And you can start creating a circuit here. So on the right side, you can see the components. You can drag and drop the components onto the main screen. So there are a lot of components here: resistor, LEDs, potentiometer, battery, Arduino. We'll be using only some of them today, not all. And here you can see the code option, which we will tell you later. And also you can share your uh, Tinkercad or any circuit you have made to any people, anyone. So invite people, copy the link and share with them. Uh, should we start making the circuit then?
Guys, react with thumbs up if you are ready with the app open. So the website.
Okay, yeah, we will start now. So first, we will need a breadboard small. You can find it here. Place it at the center. Then take a 9-volt battery. Place it on the side. And also you need a Arduino.
So for placing, just click on that and drag. It will come.
Yeah, drag and drop it at on the screen. And you also need DC motors, 2 DC motors. And yeah, you can also rotate the component by clicking on it and just rotate it. And now you need a motor driver. You can search components here and then type it and yeah, you get it. And click it and place it at the central part of the breadboard. It is mainly, yeah, it is only where ICs are kept. And yeah, so these are the components which we will be needing today. And we will start with making connections now. Yeah, first we will connect the battery to the breadboard. So connect positive to positive and negative to negative. And you
Go
can
a
also
little slow, Anish. Like, I mean, just like make one, two, three, four connections and ask them did they follow you?
yeah, yeah, we have connected the battery positive to positive, and yeah, you can also color the wires for it will be better if you color the wires. So click on the wire and you can color the positive one red and negative one black. So I guess you have uh, reached till here. Uh,
If you have any doubts, you can raise hand. We'll on your mic, you can talk. And if you're done till here, please react with a thumbs up.
yeah, I will move on to the next part. Now connect the bottom power rail to the topmost power rail. So connect the negative to negative. This will be the negative is actually the ground. We will connect all the ground pins of the IC and Arduino to the negative power rail, and yeah, and now connect positive to positive, and yeah, you can again color the wires. So yeah, we have connected the battery. Now we will connect the ground pins to the negative power rail. So say you can see the name of the pins when you go on them, and you can find the ground pins and now connect them. So yeah, also on the breadboard, you can see when I click on one hole, you can see the vertical line is highlighted. It means that all these holes are at the same voltage and these are connected. So yeah, to connect the ground, you can just uh, make a wire from here to negative, and yeah, make it black. There is one more ground pin. Ground it. There are two more ground pins at the bottom. Uh, I guess you have you made it till here? Have you made it till here? Should I like change the mic permission?
Yeah, for Farhan and another, some like two people are asking. Just allow for them and see if they ask any doubt.
Can you raise your hands? Oh, yeah, I can't find them. Like they haven't raised their hand, I guess.
Guys, if you want to talk something, raise your hands. We can't see anybody raise their hands or something. Sorry. Fine, like then.
Okay, I will continue.
Yeah.
So yeah, we have connected, we have grounded all the ground pins. No, like Arduino ground pin also is also remaining. So yeah, click on the pin, a wire will be created. And to change the direction of the wire, just click click at the position where you want to change the direction. And now you can change the direction and yeah, connect it, ground the ground wire. So yeah, now we have grounded all the pins. Now we will connect the motor to the motor driver. So there are two terminals on the motor. You can see terminal 1, 2. Uh, so yeah, click on the terminal. You have to connect the terminal 1 of the motor to the output 4 of the motor driver. So just click on the topmost hole and connect terminal 1 and similarly connect terminal 2 to output 3. Yeah, I guess I hope you have made it this. And similarly connect terminal 1 of the motor to the output 2 of the motor driver and connect terminal 2 to output 1 of the motor driver. And yeah, you can color the wires. So we have connected the motor to the motor driver. Now we have to connect the Arduino to the motor driver. So we have to connect the digital pins of the Arduino to the motor driver. So you can see there are digital pins above. We will be using the pins three onwards pins. So yeah, we will start. And yeah, also there are power pins on the motor driver. Connect them to positive power rail. There is one at the bottom right and there is one at the top left. Yeah, have you connected the power pins?
So once can you repeat this one? Power pins.
See, can you see the power pins on the motor driver? Connect them.
Yes, sir.
Yeah, so connect them to the positive power rail. This and this. Yeah, now we'll start connecting to Arduino. Yeah, now we'll connect the enable 3 and 4 pin uh, to Arduino's third D3 pin. So click on the create a wire. Yeah, so you have connected the Arduino's D3 pin to the enable 3 pin. Now you can color it, I guess, green, kit green. Now connect the input 3 pin of the motor driver to the fourth pin of the Arduino, D4 pin of the Arduino. and you can color it some other color. Uh, Now connect the input 4 pin of the motor driver to the fifth pin of the Arduino, D5 pin of the Arduino. And you can also color it blue. And now we have to connect the bottom pins. So yeah, connect the input 2 pin to D7 pin of the Arduino. So and yeah, you can color it purple. And you can connect the input 1 pin to the next pin on the Arduino. The D8 pin. The input 1 pin to the D8 pin on the Arduino. Change the color. Now the last pin, the enable 1 and 2 pin, connect it to the D9 pin on the Arduino. Also, if you like misclick somewhere, you can erase the wire. Just do escape, or you can also do undo. So yeah, connect the enable 1 and 2 pin to D9 of the Arduino, and you can change the color to brown. So, so this is the circuit which we will be using today. Uh, you can take your time making the circuit. After some time, we will start coding the Arduino. And also, if you have any doubts, you can ask. Uh, you can make the circuit by looking what I have made. Like, and if you are not able to make the circuit, we can send you the link. Uh, then send you the link. You can make the circuit later and first do the coding along with Anu. No, color coding is not important. Like, it's better for you, right? To look. See, there are so many wires and it's not easy to distinguish. Has everyone made the circuit? Yeah, I guess we'll start with the coding part.
Yeah. So like most of you are done with the circuit, right? So we'll start with the code. So in when you like you can see there is an option at the right top. We have start simulation, which will start the code that you have written, and we have the code option. So we'll click on that. And you have three options to code. One is blocks plus text, and one is text. So like we don't use these two, we'll use text. So it'll ask for some, you just continue that. And there'll be a default code here. So everyone is following, right?
Yeah, they put
Yeah,
thumbs up.
okay. Yeah. So see, we'll just run this code once. We'll start simulation. And as you can see here, this LED is blinking. This is the default LED which always remains on, which tells that your board is working. And this is what this code is doing here. So I'll explain that code to you first. So any like Arduino coding is based on C++, and it every Arduino code has two parts. One is void setup and one is void loop. So in void setup, what we do is we define everything. Like we define that this pin is going to be used for as an output or an input pin. We define that we want to start this or we'll be doing that and this. So that all is defined in the setup part. And in the loop part, you write the commands that you want to continuously execute. So like whichever commands I'll be using, I'll explain them parallelly, but I have written brief descriptions about them in the slides as well. So you can view that later as well. So the pin mode command is used to define a pin as an input or an output pin. So in this case, LED built-in is the 13th pin, which is for that L LED. So that LED, the format is that pin mode you will write. Please make sure that M is always capital. And in the bracket, the left side will be the pin number or whatever you are defining the pin as. And the right side will be its type, that is the input or output type. Moving on to the loop part. Digital write is to write like to write a value digital, that is it will be binary 0 or 1, high or low, onto that onto the a particular pin. So in this case digital write will state that I want to write high on the pin LED built in, which in this case is pin number 13, D13. So yeah, so now what happened is D13 became high, that is the board gave it high potential. After that we put a delay 1000. So what delay does it tells the program to stop here for 1 second. Like 1000 is for 1 second, it's in milliseconds. So if you put 2000, it will stop for 2 seconds and stuff. After that we again did it low so that it will stop, like we gave it zero potential. So what happened is like the pin which was given high first, it became low and the LED stopped, like the LED switched off, and then we have given again a delay. So when this command, when these commands are run continuously, it'll the LED will blink. So like everyone is following, right? Hello, everyone is following, right? Should I move? Like, should I start the main program? Yeah, okay. So for now, we'll just remove this default codes and we'll start. Yeah. So the first code that will be first we'll write the setup part, then we'll write the loop part. Okay. So in setup, first we'll write serial dot begin 9600. So what serial.begin does is, like Arduino does not have a display, right? So if you are taking some data from your sensors or if you are creating any variables, you won't be able to see their values. So what serial.begin does is it allots space on your computer. As you can see, there is a serial monitor here at the bottom. So it starts this serial monitor, and 9600 is the baud rate. So it's the 9600 bits per second. That is the rate at which the data is transferred. So that's the command. And don't forget that S is capital. Okay. So we'll start defining the pins now. So we'll write pin, and there are two ways to write a pin. Like you can define like this, has define, and let's say you want left motor 1, and that will be your, let's say, pin number 3. So what will happen is, instead of writing 3, you can write left motor while you are defining any pin or using that pin. So what this is used for is that when you are writing huge codes or when you have many components and everything, if you keep the pins as they're like, if you write pins as 3, 4, 5, 6, it will create a lot of confusion when you are writing the code. So that's when we use this defining. So we'll define pin number 3 as left motor 1, then we'll define pin number 4 as left motor 2, and like that. Today we won't do that because we just have 2 motors and 6 pins related to them. So we won't need that. But in bigger programs, you need this defining. Okay. So I'll just remove this. And yeah, so in pin mode, first we'll define the upper motor. So as Anish has connected, see, enable 3 and 4 is connected to the pin number 3. If you can see, there is this symbol here. So that defines that this pin is a PWM pin. And as I said that you need to connect enable pins to PWM pins on your Arduino. So that pin as an output pin. While writing output and input, everything has to be capital. Then we'll define the next pin. We'll now define all these pins as output pins. So for yeah, so is everyone done with this much part?
They are asking some doubts in the chat.
Yeah, so that symbol is to define that that is a PWM pin. That's why. 9600 is the rate, that is its bits per second at which the data is transferred between Arduino and the monitor or your system. So like, is everyone done with the setup part? So did I start the next part? Please do react. That I know. 5, 7 is not repeated. I just copied it to do it fast. I changed it later. See, 8 and 9.
In the screen, we can see it twice actually. Maybe your presentation, like it's lagging or something. We can see 5 and 7 twice, like same line.
1 second. I'll reshare the screen. Is it 8, 9 now? So I'll move forward, right? So like, is everyone done with this much part, defining the pins and all? Yeah, okay. So in void loop, first we'll write some basic thing to run the motor. So digital write, as I said, it writes a digital value that is 0 or 1, high or low, onto a pin. So first we'll write digital write. Again, W should be capital or it will give errors later. Okay. And if you might know coding, semicolons are very important. So digital write you write, and let's say first we'll code. If you see here the green pin for the first motor, that is it is an enable pin, right? So it is in 3. So we won't use digital write on that. I'll explain about that later. First we'll write about 4 and 5, which are the two input pins for the motor driver. So digital write 4, let's give it high. High also everything should be capital. Then digital write 5, let's give it low. And now what we'll do for pin number 3 is we'll write analog write. So what analog write is to give an analog value instead of binary values. You can write a value between 0 to 255. 255 is because it's an 8-bit thing. So 3 and let's 255 is full potential and 0 is minimum 0. So we'll give, let's say, some value 200. Okay. So this will run your motor, the one motor that is above the breadboard. And let's give it a delay 2000. So it'll the program will wait for 2 seconds, and then what we'll do is we'll stop the motor. So for stopping the motor, what we'll do is we'll just change one of the two input pins to like if you are choosing 4, you'll make it low. If you are choosing 5, you'll make it high. That is, both will be at same potential. So I'll make 4 low. So is everyone following this much? We don't need all pins to be PWM pins. We just need we just need the enabled pin to be connected to the PWM pin. The remaining two input pins can be connected to a digital pin. It's not a problem. So is everyone done with this much part? The coding for the first motor. Yeah, so what analog write is that it has the same format. Like first you write the pin number. Second, instead of high low, you write a value between 0 to 255. Like if 255 is the maximum value, 0 is the minimum value. So like why we are giving it to enable is like when I explained L293D, the motor's speed is controlled by enable pin. So the highest, like the value you give to the enable pin will be the highest that the motor can reach. So like if you see, this is a 9-volt battery, right? So if I give 255, the motor will receive full 9 volts. But if I give it like if I give it some, let's say 200, it will get less than 9 volt. Let's say it will get around 8 volt or something. We'll have to convert that. So it will get a lesser potential as the maximum value. So the speed of the motor will automatically reduce. So that is why analog write is used. Like digital write is to send high or low. Analog write is to send a value between 0 to 255. So should I continue? Like we'll write a similar code for the second motor as well. Yeah, okay. So let's not copy. We'll write the whole thing again. Just write the same thing, but this time you'll do it for the second motor, right? So the pins will be different, but the code will be same. So digital write, then you write pin number 8. Yeah. 7. So, and then you write analog write pin number 9. Let's give it a lesser speed. Let's say 100. And then we'll give a delay 2000. And then we'll reduce it back to stop. So yeah. So like now you can try to run the code. There is a start simulation button here. And if you see now, see here, this motor is running at some 1200 RPM, whereas this one runs at a 600 RPM something. So this is running at a different speed and the one below is running at a different speed because we have given 200 to the upper motor and 100 to the lower motor. So you can try it as well. Like if you are done with the code, you can try to start the simulation. And if you have any errors, you can tell me about it. I'll just do it. So like we'll wait for 5 minutes till everyone completes the code and tries to run it. we have given different RPMs just to see how it works. Like if you run the program, you will see that the two motors run at different RPM because we have given different values in analog write. So like uh, we'll start with now a serial thing. Like we'll use the serial monitor as well. Okay. So you can keep this stuff. So let's just define a character first. I'll tell you why. So we'll be using a character because like, let's say we want to do it in this way that if I give the forward command, it should go forward. If I give like both motors will go in one direction. If I give it a backward command, both will go in backward. If I give right, left, stop like that. So like we'll just use the first things, first characters F, B, left, right for LR and S for stop. So initially we want the motor to be stopped, right? We want the motors are not running parallelly because we have given a delay. So like first the upper motor will run, it will run for 2 seconds, then the upper motor will stop because of this command, the fourth line of your code in void loop, the digital write 4 low, because we gave same potential to both the input pins. Then the second motor runs, then it runs for 2 minutes, like 2 seconds, and then again it will stop. Okay, yeah. So we are defining this character and we'll define it initially as S because we want the motors to be stationary in the initial condition, like the basic condition. So to take input from the serial monitor, we'll write the command serial dot read. Read means that it will read from the serial monitor. And since we want C to be read, we write C is equals to serial dot read. So whenever we write F or let's say any character, it will read that. Now, depending on the time, we'll just do it for two things. Let's say if, like, if, yeah. So if you're familiar with any programming language, you might know about if else. If you don't, I'll just tell in bit, short, simple. So if else is a conditional statement. Like if in the bracket you write some condition, and if that condition is true, it will run the code that is inside that statement, like inside if. And if that condition is not being satisfied, it will run the else part. So in if, we'll write C equals to F. And we'll give a bracket. Yeah. So in that, we'll just write again digital write bracket 4 comma I. The same thing you can copy, just the one that we left. And now we'll remove the delays and the stop commands because now the motors will be run by the conditional statement. So we don't need them. So we'll remove the delay and digital writes after the delays. And we close the curly bracket. So if you see this, what we are doing is we wrote a condition that is if C is equals to F. So equals is an operator which compares them, and the curly brackets are to state that the if statement starts from here and ends here. So usually it is not necessary to write it with a tab, but we usually give it a tab because then it is easy to understand later in bigger programs. So like this space here. In digital write, we just wrote the same thing again, 4, 5, high, low, and analog write is the same. We'll just give the same speed, let's say, to the other motor as well. So now both motors will rotate in a fixed direction. Like let's say the previous motor was in negative, right? So we'll just flip its direction. So see, to flip the direction, we'll just like first pin number 8 was high and 7 was low, right? Now we'll make it reverse. So now pin number 8 is low and pin number 7 is high. So now the below motor was giving a negative value in RPM, right? So now it will give a positive value. Speeds are again the same. We just gave it same speed because we want it to go forward and not turn. So after an if, we write else if because like we wanted to check for four things, right? Forward, backward, left and right. So that's why we'll ask for else if. Then we write c equals to backward, let's say, and we'll write this. You can again copy this same thing, digital right, the one which is in the above if. Like this, I am copying because it is fast. It is also better for you if you learn to copy and write. So once you do that, just flip the directions or wires. Like now, it depends on you what you want to do. Like if you want better management, you can write, you can change the high lows. If you want it to be fast, you just change the pin numbers like 4 and 5. You can reverse them. But like for now, I'll just change the direction. So I made this low and this high. Then again this high and this low. So now if you see, everything is reverse compared to the forward command. All right. And we forgot to write close the else if statement. So that the curly bracket. Everyone is following, right? Till now. So, so everyone is done with this much part. So I'll just show like for forward and backward how it's working. Let's start simulation. And you can click at the bottom of your screen. There is a serial monitor thing. You press on that. And now the motors are stationary if you see, right? So let's write F and enter. So now both motors are moving forward, let's say. Both have the same speed as you can see. Let's do it backward. Now the directions are flipped. See, the above one was positive, now it became negative. The below one was negative, now it became positive. So it's moving in the opposite direction. So you can just try this as a trial. And I'll stop the simulation. So do you have any doubts regarding this? We can write about right left as well, but like you can do it as well. If you want, I can write about right and left as well right now. So like, do you have any doubts in this code? Yeah, so like unless you enter forward or backward, it won't move. So open the serial monitor and enter F or B, like whichever you want, and then it will run. So like, should I include left and right as well? I can write it. So like for left and right in robots, like you can do many methods. One is to like if you have two motors, left and right. So you can make the left motor rotate anti-clockwise, and you can make the right motor, like you can make one wheel move backward and one wheel move forward. So the robot will turn on its position itself. The other method is you can stop one wheel, you can increase the speed of the other wheel. And one is to, like, one wheel will move slowly and the other will move fast. So it will turn to the direction that is the wheel which is moving slowly. So like there are multiple methods to turn your robot. Did you define S? Like if your motor is running initially. So like the forward and backward thing is not applicable on a simulation Tinkercad, because when you are using an actual, like when you are using the actual components and you make a robot in a physical state, you will have to check the what we say. Yeah, you will have to check the terminals in order to see how the wheels are moving. Like you'll use the motor and everything, but once you code and you see, you'll have to try and error, like which with which high and which low it is moving forward or backward. So you'll have to adjust that according to your physical state. In the simulation, it doesn't matter much. Yeah, the one who sent the image of his circuit. You have connected the positive of your, like the power of your L293D right bottom. Did you see the red wire, the small one? They have connected it to the negative terminal, connected to the positive one. And the same thing you have done in the left side as well. The two long red and black wires, you have connected the positive to negative and negative to positive. Like that's why it's short circuiting. Yeah, the code is this much only. This is the whole code. Like for left and right, it's not, I can write here if you want, but it's also in the slides. Did you delete the first code, like the one we wrote before writing if else commands? Please do delete that. Otherwise, it will run even if the conditions are not satisfied. So like once you add these conditional statements that you want the code to run depending on your instructions, you'll have to delete the old code, the one that went down. Just delete that and then it will work. So for errors, make sure that there are semicolons everywhere. and you have written digital writes W capital, pin modes M capital, in serial dot begin or serial dot read the S is capital. Like these are small errors which usually cause problems. Yeah, so like the code for the left and right is the same. I have used that one wheel is slow and one wheel is faster. It's in the slides. Like if you want, or you can experiment with it as well. It's not that hard. You just have to use the same thing, but you'll have to change the speeds, or you'll have to stop one motor and the other will keep running like that. Apart from this, if you would like to learn more about Arduino's coding, the all these commands or functions are there on Arduino's official website. Like if you search for serial, all commands related to the serial monitor are there, and there is pin mode, digital light, everything is there on Arduino's website. So like, do you guys have any more doubts? Uh, Kashi Vishwanath, you still have connected the power cord of the L293D, like the right bottom. Connected to the negative, connected to the positive. That depends on like your connections. Like the RPM is positive, negative, depends on high low. How you are giving the RPM's direction doesn't matter much in your sim. Like when you're doing it in physical, you'll have to check it with your like you'll have to check it with try and error. Like which if you make high low, how you'll the direction and all that. So second. Yeah, you can use int instead of character, but then you'll have to use like you'll have to define that 0 is for stop, 1 is for forward, 2 is for backward, and that. Like if you use int, you will have to define things for forward, backward. We use character because it was easy to do. Like forward is for f and that.
So yeah, we have come to the end of the session. Yeah, we looked over some basic sensors and microcontrollers, and we like learned how to make a circuit on Tinkercad, and Anup told you about Arduino programming. And yeah, we made the final circuit for running two motors using L293D motor driver. And also feel free to ask any doubts. And yeah, also for the next session, please download MATLAB. Uh, we will be using MATLAB in the next session, so download it. And thank you.
So, yeah. Thank you guys.
You can ask doubts if you want.
Yeah, and you can send your doubts on the channel as well, I guess, if you have permissions. I am not sure.